We're going to cover a basic introduction to matrices. A matrix, and the plural of matrix is matrices, is a rectangular array of variables and constants, usually enclosed in brackets. Each value in a matrix is called an element, and usually we use an uppercase letter to name a matrix. So really, a matrix is just like a fancy table. Each element in this matrix we refer to by its row and column. So for example, -1, we could call, since it's in the second row and the first column, you write this as A21. That's not A21, that's just shorthand to say it's second row, first column. If I was talking about this +1 over here, that's in the third row and third column, so this would be A3, 3. Yeah. So a matrix can be described by its dimensions. So this is a 3 by 4 matrix because it has 3 rows and 4 columns. If it had m rows and n columns, it would be an m by n matrix. Notice I pronounce the multiply sign as by. So adding and subtracting matrices is really simple. First of all, they need to have the same dimensions. And if they do, then you can add or subtract them. So for example here, to add and subtract these two matrices, you just add the elements in the corresponding places. So to add these two matrices, the first row, first column, I just add the 1 with the 2. So 1 plus 2 is 3. And similarly, 3 plus 5 is 8. 4 plus -6 is -2. -3 plus 12 is 9. And that's all there is to it for adding matrices. Multiplying matrices, you have two ways to multiply a matrix. One is you can multiply it by a scalar, which is just a fancy way to say a regular number. So to multiply a matrix by a scalar, you just multiply each element in the matrix by that number. So for this example, I'm just going to multiply every single one of these elements by 3, and that gives me my new matrix. 3 times 3 is 9. 3 times 6 is 18. 3 times -4 is -12. 3 times 15 is 45. And that gives me my new matrix. For this third example, notice that we have multiplication and addition. Matrices actually are going to follow the same kind of order of operations that numbers would. So in order to add these matrices, first I need to multiply by the constant numbers on the outside. So 2 times 3 is 6. 2 times 1 is 2. 4 is 8. 2 times 6 is 12. And 4 times -3 is -12. 4 times 4 is 16. 4 times 1 is 4. 4 times 5 is 20. And then we just add like the previous example. So 6 plus -12 gives me -6. 2 plus 16 is 18. 8 plus 4 is 12. 12 plus 20 is 32. So, pretty simple so far. Multiplying two matrices together gets a little bit weirder. It's not as simple as just multiplying like the numbers as you would with adding. So first of all, you can only multiply two matrices together if the number of columns in the first matrix you're multiplying is equal to the number of rows in the second matrix. So for example, if A was an M by R matrix and B is an R by T matrix, notice they both have so the number of columns in A is equal to R, the number of rows in B is equal to R. So since these are the same, these can be multiplied. And when you multiply them, the resulting matrix will be an M by T matrix. So it's the columns of the first and the rows of the second. So A, B is is an M by T matrix. So before we get to multiplying matrices, let's just practice with figuring out whether these matrices can be multiplied and what type we'll get. So if A was a 3 by 4 and B was a 4 by 2, so first of all, we can multiply them because 4 and 4 are the same. The two inner numbers are the same. And the result is these two outer ones. So AB is a 3 by 2. It would have 3 rows and 2 columns. If we look at this example here, 2 and 3 are not the same. So AB cannot be, AB would be undefined. All right, now let's get to actually multiplying matrices. So when you multiply matrices A and B, the element of the mth row and the rth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and the column R of matrix B. If that didn't make sense to you, don't worry. It barely makes sense to me, and I grabbed it out of the textbook. It makes more sense when you do it. So if you look at this, this example here with just variables, you can see that the first element of AB is the row 1 column 1 element of AB is A times E plus B times G. And we get those numbers from, here's the first row of A and the first column of B. So we did A times E and then B times G. Then to get the second element, notice it's A times F plus B times H. So it's the first row again, A and B, but now they're being multiplied by the second column, A times F and B times H, and so on and so forth. To get the second row, we use the second row of A and multiply by the 2 columns of B. So let's do an example down here. If we're multiplying these two matrices, to get my first row, first column entry of AB, I'm going to multiply 2 times 4 and then add that to -1 times -7. And that's just my first entry. To get the first row, second column, again, I use 2 and 1, so it's going to be now 2 times 2, and then added to -1 times 6. And that's going to be the first row of this new matrix, right? And then the second row, now I'm going to use the second row of A and multiply by the first column of B. So 3 times 4 plus -2 times -7. And then for the last entry, it's the second row of A again, so 3 times second row of A, second column of B, so 3 times 2 and plus -2 times -6, +6. So plus -2 times 6. And then I would just simplify all of this. So my resulting matrix is, so 2 times 4 is 8, and then, oh, there's a plus missing here. 2 times 4 is 8, and then -7 times -1 is +7, so that's 8 plus 7 is 15. And 2 times 2 is 4, and then -6, that gives us -2. Here we get 12 plus 14, so that is 26. And lastly, we get 6 minus 12, that's -6. And this would be the result of multiplying the two matrices together. And notice, since we multiplied a 2 by 2 with another 2 by 2, the result was a 2 by 2. And that's always going to be true for, if you have square matrices, then you multiply two square matrices together, you'll get a third square matrix. So this last example is actually less work than the previous one, because here we have a 2 by 2 and a 2 by 1. So the result, so we can multiply them because these are the same. And our result is going to be a 2 by 1. So we take the first row of A and multiply by the only column of B. So 1 times -3, and then add it to 4 times 5. And then we use the second row of A, so -2 times -3, and then add it to 3 times 5. And that's it. Since there's only one column of the second matrix, we just simplify this, and we'll get a 2 by 1. So this is going to be -3 plus 20, so -17. That's +6 plus 15 is 21. And that's our resulting 2 by 1 matrix. All right, that's going to conclude these notes.